Students, in the last session we discussed about the different types of coordinate system and their differential elements, differential surface elements, and the differential volume. And in this session, I am going to cover the following topics. The one is Coulomb's law, which is very important for examination point of view. And next thing is how to express the Coulomb's law in vector form. And third is experimental law of Coulombs. So what the St. Augustine D. Coulomb performed the experiment and what he concluded. So these things we are discussing in this session. Let's start with the Coulomb's law. See, so in this you have to study what is the statement of the Coulomb's law, how to derive the expression of the force and their units. Coulomb's law states that the force between any 2 point charges is directly proportional to product of the magnitude of the two charges and inversely proportional to square of the distance between them. See, you are observing the 2 point charges, say Q1 and Q2, in the free space which are separated by a distance r. As I told you in the statement of the Coulomb's law, force is directly proportional to product of the magnitude of the two charges, which means F is proportional to Q1 into Q2. And also I told you the force is inversely proportional to square of the distance between the 2 point charges. That is, R is the distance of separation between the point charges Q1 and Q2. Square of the distance means R square, and F is inversely proportional to R square, means F is proportional to 1 by R square, that is inversely proportional to R square. Combining the two terms, we can get F is proportional to Q1 Q2 by R square. By removing the proportionality symbol, we can write the constant. K is the constant of proportionality. Therefore, F is equal to K into Q1 Q2 by R square. The constant of proportionality K is equivalent to 1 by 4 pi epsilon. Dear students, in the electrostatics, we are using the constant called permittivity, that is denoted by the symbol epsilon. This epsilon is the product of epsilon naught into epsilon r, where epsilon naught is the absolute permittivity of the medium and epsilon r is the relative permittivity of the medium. Epsilon naught has got the value of 8.854 into 10 to the power of minus 12 farads per meter. Farads per meter is the unit of the permittivity, and epsilon r is equal to 1. Hence, epsilon becomes epsilon naught for the free space or the vacuum. Therefore, F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. And this the permittivity, absolute permittivity, epsilon naught is also equal to 1 by 36 pi into 10 to the power of minus 9 farads per meter. Then K is equal to 1 by 4 pi epsilon naught. So substituting epsilon naught is equal to 1 by 36 pi into 10 power minus 9, you will get 8.98 into 10 to the power of 9 is equivalent to 9 into 10 to the power of 9 the meters per farads. So this is the value of the K. So hence Coulomb's law can be expressed as F is equal to Q1 Q2 by 4 pi epsilon naught R square. In the problems, we can use straight away F is equal to 9 into 10 to the power of 9 Q1 Q2 divided by R square. Since F is an vector quantity, the force is a vector quantity, therefore we need to express the Coulomb's law or force in the vector form as vector F is equal to vector F2 is equal to Q1 Q2 divided by 4 pi epsilon naught R12 square into A12. What is F2? F2 is nothing but it is the force which is exerted on the Q2 due to charge Q1. See, you are also observing the force F1 which is exerted on Q1 due to charge Q2. R12 is the distance between the point charges Q1 and the Q2. O is the origin. So between O and Q1 there is a distance called R1. Between O and Q2 there is a distance called R2. Using the vector addition or addition of the vectors, we can write R12 is equal to what? R2 minus R1. And now direction of the unit vector, that is A12, which is the unit vector along the R12, that is vector divided by magnitude of the vector. Therefore A12 is equal to R12 vector by modulus of the vector R12. So we can get R2 vector minus R1 vector divided by modulus of R2 minus R1 vector, where R12 is the distance between the two charges. So refer to the figure, the force F1 which is exerted on Q1 due to Q2, this I already told you. It can be expressed as F1 is equal to Q1 Q2 by 4 pi epsilon naught R2 1 square into A21, nothing but Q1 Q2 by 4 pi epsilon naught into R2 1 square into R1 vector minus R2 vector by modulus of R1 vector minus R2 vector. Suppose if you want to find F2, see F2 is nothing but, see both F1 and F2 whose magnitude are same, magnitude of the force F1 and F2 are same, but the directions are different, that you observed, that you noticed in the figure. Therefore F1 is equal to minus F2, which means that magnitude of these two force vectors are same, but the directions are different, means A21 is equal to minus A12. So hence the force exerted by the two charges on each other is equal but opposite in direction. Nature of the force. Dear student, try to understand what is the nature of the force when both the charges are like. What is the nature of the force when both charges are unlike? When both the charges are like, which means either both the charges are either positive or either negative, by the time the force is repulsive in nature, means so the force is repelled from the charges or repulsive in nature. When the charges are opposite, then force is attractive in nature. So in the figure A and figure B, you are observing that force is repulsive in nature, means which is moving away from the charges. But in case of figure C and figure D, the charges are unlike. Therefore, force is attractive in nature, means which is attracted towards the charges. Charges are attracted with each other. So this is about the nature of the force for the different types of charges. Experimental law of Coulombs. Saint Augustine de Coulomb, the great the physicist, who conducted an experiment. What that experiment? That experiment consisting of a non-conducting rod which carries two spheres. One is a charge, another is counterpart, and this is suspended by the suspension wire which is shown in the figure. So these two charges named as B and B dash. Later, so he brought one more charge sphere which is standing on the non-conducting support near to the charge sphere B. So when the charge A brought near to the charge B, the non-conducting rod start rotating. So when the non-conducting rod start rotating, the wire becomes twisted, and the angle of the twisting of the wire is increases as the number of turns increases. So at the end, the Coulombs measured the force by changing the length of the charged spheres. So finally concluded that the force of attraction or repulsion between the 2 point charges is directly proportional to product of the magnitude of the two charges and inversely proportional to square of the distance between them. So this is what Coulomb's experimental setup, and from this experiment the Coulombs had given the statement so how the force of attraction or repulsion between the point charges is proportional to magnitude of the product of the magnitude of the two charges and inversely proportional to square of the distance between them. So dear students, the force is measured in newtons. So as per the Coulomb's law, we can also write the units of force as what is that Coulomb square divided by meter square. So thank you for watching this